Okay, welcome back. This is our second and final snow day video on logarithmic and exponential expressions and equations. And I decided just to do two videos because I want you guys primarily focusing on the take-home test that I gave you. The take-home test is more important. And because I'm late getting these videos up, I'm going to give you guys until Tuesday to get these done. So the work for these videos is due by Tuesday, and there's a total of 7 problems. So 4 on the last video and 3 on this video, and there's not a lot of difference between these 3 problems and the ones on the previous video, except that these three require one extra step. But before we actually look at the problems, let's just talk about log for a moment. See if you learned, maybe you caught this in the last video, or maybe you did not, I don't know, but I want you guys to start practicing this. Log base 3 of 3, log base 3 of 9, log base 3 of 27. I want you guys to get to the point where you don't have to actually solve an equation, but you can actually tell me the value of this expression. What are you looking at here? What is log base 3 of 3? What is this? This is an exponent. Okay, so your answer is an exponent. When you can get to the point where you can look at this and just tell me the value without doing any work, then we can just work in one category called the expressions. It's much faster if you just stay in one realm here instead of bouncing over to the equations. If you can look at this and tell me what the answer is without doing any work, it's much faster. Watch. The answer is the exponent. Notice that what lies on the outside. This thing is equal to what? This thing is equal to an exponent. So we're asking 3 to what power is 3? Well, if you think 3 to what power is 3? Well, 3 to the first is 3. I'll just show you many examples. You'll start picking up on this. 3 to what power is 9? 3 to what power is 9? Well, that's 2, so the answer is 2. 3 squared is 9. You're reading it as 3 to the first power is 3. That's your exponent. This is your exponent. Notice 3 squared is 9. 3 to what power is 27? Well, 3 to the third power is 27, so our exponent, our answer is 3. Now let's look at log base 2 of 2, log base 2 of 4, log base 2 of 8. We're asking 2 to what power is 2? Well, 2 to the first power is 2, so our answer is the exponent 1. 2 to the first power is 2. 2 to what power is 4? Well, 2 squared is 4. Exponent is 2, so 2 squared is 4. This is your exponent. This is your answer. Now, 2 to what power is 8? Or what is the exponent that we need to put on a 2 to make 8? 2 to the third. Okay, so 2 to the third power is 8. Therefore, our answer is what? The exponent, which is 3. Now, let's go back to this. Let's look at log base 3. Log base 3 of 1. Okay, that's the question. Log base 3 of 1. 3 to what power is 1? This one's really important. 3 to what power is 1? 3 to what power is 1? Well, 3 to the 0 power is 1, so our answer is 0. The exponent is 0. Okay, so look at this. Log base 2 of 1. Whenever we have a 1 sitting here, 2 to what power is 1? 2 to the 0 is 1, so 2 to the 0 power is 1. Our answer is an exponent of 0. Let's look at this. Just a little exercise for you guys to get thinking. This is not required. It's part of your homework, but I just want to get you guys thinking in terms of how to read a logarithmic expression. Let's look at log base 10 of 1, log base 10 of 10, log base 10 of 100, and log base 10 of 1,000. Okay, so the question is, 10 to what power is 1,000? 10 to what power is 1,000? Well, 10 to the third power is 1,000. 3 zeros, third power. Okay. 10 to what power is 100? Okay. 10 squared is 100, so our answer is the exponent of 2. 10 to what power is 10? Well, 10 to the first is 10, so the answer is 1. The exponent is 1. 10 to what power is 1? 10 to the 0 is 1. 10 to the 0 power is 1, so our answer is 0. Now, we're going to notice something here. Notice you have base 10, base 10, base 10, base 10. Okay, when we have a base 10, it's convention not to write the base. So let's look at another way of writing this. We can just write log of 1, log of 10, log of 100, and log of 1,000. Okay, so notice what is not written. We call this common logarithm. What is not written? Okay, the common logarithm has a base 10. The base is unwritten. Okay, the base is not written. So if the base is not written, we call this the common logarithm, and we assume that the base is 10. So notice our base is unwritten. If the base is unwritten, the base is assumed to be 10. So we're asking here 10 to what power is 1,000? The answer is 3. 10 to what power is 100? The answer is 2. 10 squared is 100. 10 to what power is 10? This is 1. And 10 to what power is 1? Well, 10 to the 0 power is 1, so our answer is 0. So if the base is unwritten, we call this common logarithm, and this is assumed to be base 10. Or I should say it like this. Do we have to write base 10? Do we have to write the base 10? No. We just write log. So if you see log of 100, you assume that the base is 10. If the base is unwritten, the base is assumed to be 10. All right, now, let's go to the examples. There's only 3 problems for homework tonight. That was just a little exercise to get you guys thinking in terms of log expression. And I want you guys to get to the point where you can look at this problem, log base 8 of 512, and you say 8 to what power is 512? 8 to what power is 512? Well, the answer is 3. Okay, 8 cubed is 512. But if you don't know that, we can just work this out remember, we can say to find the value of this expression, to find the answer, the value of this thing is 3. The answer is 3. To find this value, remember expressions have values, we can move over to the realm of equations and set this up as an equation. So say equals something, okay, equals something that we don't know. So we're going to call this y, equals y. This is covered in the last video. So now we're going to say the base is 8. Okay, write base. The exponent is y. Now we're going to say that 8 is our base, write it larger, and the exponent y, write it very small. 8 to the y power is equal to 512. And now you just have to factor everything down to the same base. So we're going to take the 8 and break it down to base 2. So we're going to say 2 times 4, which is what? 2 times 2. How many 2's multiply to give 8? There are 3. So we're going to write 8 as 2 to the third. And notice we have a y on the outside. So 2 to the third, 2 to the y power. Put the 2 to the third in parentheses. And take the 512 and break it down. 512 is 2 times 256, which is 2 times 128, which is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, 2 times 4, 2 times 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So we're going to say that 512 is 2 to the 9th power. Now, the only extra step you have in this problem is notice we have power of power. So 2 cubed to the y power, reminding you, what is x squared to the third power? When we have power of power, what do we do with the exponents? We multiply them, and we get x to the 6th power. So we're multiplying exponents here. When you have power of power, or 3 to the y power, you have power of power, we multiply. We get 2, and when we say 3 times y, we glue it together, 3y. 2 to the 3y is equal to 2 to the 9th. Now, notice, since these are equal and the bases match, it must be the case that the exponents are also the same. So since 2 matches 2, it must be the case that 3y is the same as 9. So we're now going to write 3y, logically, 2 to some power is 2 to the 9th. 3y must be the same as 9. Now divide by 3, and we get y equals 3, and that is our answer. Okay, now we check it. I always want you guys to check your answer by plugging the 3 back in. So we're going to say log base 8 of 512 is equal to 3, means that the base is 8, the exponent is 3, this is your exponent, this is your base, 8 to the third is equal to 512, and if you do 8 to the third, you get what? 8 times 8 times 8, which is 8 times 8 is 64 times 8, and 64 times 8 is 512 equals 512. And you are done. You have checked your answer. So this is just like problem number 1 on your homework. Now let's go to problem 2. Something very similar to problem 2. Okay, problem 2 is just like this example. Log base 32 of 2. Okay, so this one's a little trickier. Now, in fact, just to figure this out in your head is a little tricky. The answer here is negative, let's see, hold on. 32 to the 1/5. The answer is 1/5. Yeah, the answer is 1/5. So you can actually figure this out in your head when we, but we're going to set it up as an equation. Yeah, this is not as easy to figure out in your head, but still, you do have the skills to do this. I was thinking there for a moment that this is something we haven't covered yet. No, this is radical. Okay, so we're going to say that this is set up, this is equal to something that we don't know. Something is y. Now the answer to this problem is 1/5. Okay, so we're looking at log base 32 of 2 is equal to y. And soon you guys will be able to answer this as, we know the answer is 1/5. Okay, but I'm just going to cross this out as though we don't know this. We say this is equal to something y that we have to find. So we're now going to say our base is what? Base is 32. E for base, y is your exponent. And so 32 to the y power is equal to 2. And now we're going to take everything and factor it down to the same base. You cannot factor 2, but you can factor your 32. So break 32 down. 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is what? 2 times 2. How many 2's multiply to give 32? Well, you see 1, 2, 3, 4, 5. So we're going to say 2 to the 5th is 32 to the y power. So put parentheses around 2 to the 5th. 2 to the 5th power is a replacement for 32. Put parentheses around it to the y power is equal to 2. And when we have power of power, what do we do with the exponents? We multiply. So we get 2 and multiply the 5 and the y. 5 times y is just 5. Y equals 2. Now, if the bases match and these are equal, it must be the case that the exponents also match. So if 2 matches 2, it must be the case that 5y matches. What is unwritten here? Well, the unwritten exponent is a 1. 5y must be the same as 1. So we're going to say that 5y equals 1. Divide by 5, we get y equals 1 over 5. Divide by 5, I'll show you. Divide by 5, what is this? Y equals 1 over 5. Okay, so y equals 1/5. So our answer is what? Answer is 1/5. Let's check it. This is quite interesting. This is actually radical. Okay, so we're checking that y is 1/5. So we're going to put 1/5 back in for y, and we get log base 32 of 2 equals 1/5. So you're going to see that it was necessary to cover radicals first. There's one other part of this that can't be covered yet, quadratics. So we haven't talked about quadratics yet. So part of your logarithmic equations and expressions we can't do yet. But this one, I was worried at first that I put in a bad example up here, but no, this is the radical example. So we end up with base is 32, and exponent is what? So this is our base, this is our exponent. 32 to the 1/5 power equals 2. 32 to the 1/5 power equals 2. Now, exponent of 1/5, remember, this means our index is 5, so we say this is the 5th root of 32 equals 2, and let's see if this is true. So the 5th root of 32 equals 2. Now, break down to 32. This is the 5th root of what? 2 to the 5th is equal to 2, and we take out a group of 5 2's. Group of 5 2's comes out, becomes just a 2. So we have 2 equals 2, and this checks out. All right, one more, like example 3. Let's see. Log base 1/5 of 3,125. The answer to this problem, okay, without doing any work, the answer to this problem is negative 5, I believe. Yeah, negative 5. So you should be able to look at this and tell me the answer without doing anything. That's called evaluating the expression. But since we're not strong with this yet, we're going to take the expression, convert it to equation. So we're going to say, well, since we don't know what this is, we're going to call it equals something, equals y. And now we're going to say the base is what? Base is 1/5. The exponent is y, so we're going to say 1/5 to the y power. Base is 1/5, the exponent is y. 1/5 to the y power equals 3,125. And now what you have to do is take 3,125, break it down. 3,125 is 5 times 625, which is 5 times 125, which is 5 times 25, which is 5 times 5. How many 5's multiply to give 3,125? Well, there are 5 of them, so we say 1/5 to the y power is equal to 5 to the 5th power. And now, what are we going to do? Well, we're going to take this 1/5 and we're going to convert it to a 5. How do we do this? We take the 5 and move it back to the top, inside. 5 moves to the top and becomes what? 5 to the negative 1 to the y power is equal to 5 to the 5th. Now hold on. Okay, reminding you, 1/5. Guys, what is 5 to the negative 1 power? If I said, what is 5 to the negative 1? You take it and move it where? You move it to the denominator and you get 1 over 5 to the first. Okay, so what if I say 6 to the negative 1 power? 6 to the negative 1 moves where? It moves to the denominator, and we get 1 over 6 to the positive 1 power. So remember, negative exponents mean move from top to bottom. Well, since you have 1 over 5, you're starting with 1 over 5. You're taking the 5, moving it back to the top. If it moves to the top, the exponent changes from a positive 1 to what? To a negative 1. 5 to the negative 1 over 1. And we don't write over 1, so we just get 5 to the negative 1. Okay? So if you had 1 over 6, you would take the 6, move it back to the top, you would get 6 to the negative 1. So we're converting this back to base 5. So taking the 5, moving it back to the top, we get 5 to the negative 1 power, and this is a representation of 1/5. Now, you have negative 1 power, you have y power. What do we do when we have power of power? We multiply them. So we get 5 to the negative 1 times y is negative y equals 5 to the 5th. And since our bases match, we can also say that it must be the case that the exponents match. So we can say that negative y equals 5, negative y equals 5, divide by negative 1, divide by negative 1, we end up with y equals negative 5. And now we have to check our answer. So to check your answer, and if your answer does not check out, you did something wrong. You have to go back and find your mistake. So we say log base 1/5 of 3,125. We're claiming that this is equal to negative 5. Now our base is 1/5, so we have 1/5 to the negative 5 power is equal to 3,125. And remember, negative exponents on the outside mean what? Flip it, and make the outer exponent positive. So we're going to flip the 1/5 and make this 5, and change the outer exponent to positive. 5 to the positive 5 equals 3,125. And now 5 to the 5th power is 5 times 5 times 5 times 5 times 5, which is 3,125 is equal to 3,125, and it checks out. And good luck with your homework. I'll see you guys Monday.